In this video, we're going to take piecewise functions and we are going to write what their function is. So example 6 says the graph of a piecewise defined function is given. Write the definition for the function that best describes the graph. So I can see I have two equations. So I know I'm going to have two equations here. And it's almost easiest to kind of do this portion here. So I'm going to start with that. And I can tell on this one here that this is if my function goes from, and you want to look at those x coordinates here, if it goes from -3 to 0. So this will be if -3 is less than or equal to, because it does have a closed circle here, is less than or equal to x, which is less than, again, or equal to, because a closed circle, to 0. So then the second one here, the criteria is if it goes from 0 to 2. Now, you can't have a criteria where it equals 0 in two different spots. It has to equal 0 and 1 and no more than 1. It doesn't actually have to equal 0. Well, it does if it's a function. Sorry, I'm talking through this. So because these are functions, it is going to have to equal it in one spot. So what I'm trying to say here is instead of this being, and don't write this down, instead of this being from 0 is less than or equal to x, which is less than or equal to 2, you cannot have this equal 0 in two different spots. So one of these can equal, but not the other. So if you want to take this one away and make this one just less than 0, then that's fine. But I'm going to take it away from here. And because it's going to share the same spot, it really doesn't matter which one is which. Okay. So that's the easy part. The harder part is finding out what these equations are. Luckily, these are both, and even on this one here, they're all linear functions. And linear functions are y equals mx plus b, where we need the slope and I need the y-intercept. So on this first one here, my slope is from this point to this one, we're going to rise up 1, 2, and then we're going to go 1, 2, 3. Sorry, from here, we're going to go up 1, 2. And then we're going to go to the left, 1, 2, 3, which is a -3. And then the y-intercept, or the b, where is it crossing this y-axis? Right here at 0. So my equation is 2/3 x. I can put plus 0 here if I want, but I don't really need that plus 0. I'll go ahead and put it, but that's not really necessary. Okay, so do the same thing to this one. We need to figure out what is the slope and what's my y-intercept. Well, this one has a slope going from this point to this one, goes up 1, 2, 3, and then runs. So from this point up 1, 2, 3, and then runs 1, 2 in the positive direction. So this is 3 over 2x. And then where is it crossing this y-axis? Right here at 0. So this is again plus 0. And you don't really need either of these plus zeros. So that would have been fine right there. This should have been -2/3 x, because that's my slope. It's going down. And then this one, 3 over 2x, and it's going up. Okay, let's try again. I again have two lines, so I know I have two equations. In this portion, the condition is always the easiest. So in this one, it is starting at 2 and it has a closed circle. And it's going to use all of these x values that are less than 2. So this is if x is less than 2. And I made a little bit of a mistake here. We already said this is a closed circle, so this is when x is less than or equal to 2. So then this one here starts at 2, but it's going to keep using all of these x values that are bigger than it. So this is x is greater than 2. Okay, I am still using y equals mx plus b because these are straight linear functions. So on this first one here, my slope looks like I have a point here, a point here, a point here, a point here, and it keeps going. So all of these are going up 2 and to the right 1, up 2 to the right, or sorry, to the left 1, up 2 to the left 1, up 2 to the left 1. So this is up a positive 2 and then to the negative 1. So this is 2 over negative 1, which is the same as negative 2. And then it's b, or y-intercept. Where is this crossing its y-axis? Right here at negative 1. So this first line here is negative 2x minus 1. And then we got to figure out the same things for this other one. My slope of this one, notice it's got a point here, a point here, a point here, here, here. It's going up 1 to the left 1, up 1 to the left 1, up 1, negative 1, up 1, negative 1. So this is 1, negative 1, which is the same as negative 1. Now this one's not crossing the y-axis, but we can figure that out. If I keep going with my slope of up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, if it continued, it would go right here through 4. So my b is 4. So this equation will be negative 1x, or just negative x plus 4.